This video, we're going to determine terms and properties related to sampling techniques. These are our questions from 12.1, and they're all definition type questions. So I have filled in the bubbles here for you to complete the definitions. We'll just go through them here. So the first question, the art and science of gathering, analyzing, and making inferences or predictions, parenthetically there, from numerical information obtained in an experiment is called statistics. So what we're going to be studying here in chapter 12 is statistics. So we collect data, see if there's a pattern, see if we can make inferences or predictions from that data that may have a pattern to it. The collection, organization, and analysis of data is called descriptive statistics. So we look at the data and things like mean, median, mode, standard deviation, so on, these numbers that describe the data set and are descriptive of what we've collected. So the size of the data set, so on. Next one, a subset of a population used by statisticians to make predictions about a population is called a sample. So the population is usually too big for us to get data on all of it. We usually don't have a way to compel everyone that is in our population to answer the question. That's the idea of the census. So you're going to see word census that comes up with a population, but we usually sample a subset of that population to get our sample, and we hope that that sample is representative of the entire population. So the way that we hope to do that is with our next definition, with what's called a random sample. If a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn, the sample is called a random sample. The opposite idea of that is bias in our sampling, where we have unequal chance of somebody being selected. And an example of showing bias in your sampling is you may forget that your statistics assignment is due, and you have to ask 5 people to answer your survey question. And so you turn around and you ask the 5 people in your row in class, right? That sit, they're in exactly the same class with the same teacher at the same time. They even sit on the same side of the room as you. You know, everything about them pretty much is the same as you. And you showed a lot of bias in that sampling because you didn't give everyone a equal chance to answer because you needed a quick answer, right? You needed something convenient. That's called convenience sampling. When you do that, and it's not always bad, but it usually leads to a lot of bias in the sampling as opposed to a purely random sample where everyone has an equal chance of being selected. An example of a random sample would be if we had a list of student ID numbers of students that were active, whether they were in person or online, and you used a random number generator to select just the ID numbers. You didn't even look at the students' names or demographics or anything about them. You just selected them randomly through a random number generator process using their student ID numbers. And you got the 5 students that you were going to email the survey to that way. All right, fill in the blank with the appropriate word or phrase. When a population is divided into parts called strata, for the purpose of drawing a sample, the procedure is known as stratified sampling. You're going to look at strata, and these strata are usually things like age groups. So you want to select some people in a particular age group and another set of people from another particular age group, and so on like that, so that so that people from every strata are represented, so you don't get everybody in your survey is old, or everybody is young, or everybody is in the middle. You get the idea. Something like that, that you break them up into these strata that don't overlap. And so that's a little bit different from clusters, because it's possible for people to be in more than one cluster, but it shouldn't be possible for people to be in more than one strata. Okay. Read your textbook. There's a lot more information in there in 12.1 about different sampling techniques, and there were just a few definitions here that were important that we're going to talk about later with these different sampling techniques, but there's all kinds of other sampling techniques that it's important for you to know which ones have more bias and which ones have less bias. The ones that have more bias in them are easier usually than the ones that have less bias in them. And we want to get as unbiased as we can, though sometimes we don't have all the money and resources to go completely unbiased. So we go for a good result as opposed to a perfect result sometimes in statistics. There we go. That's it for 12.1. Next time we'll come back and talk about 12.2.